Hello everyone. I hope you all are good and you all are practicing questions. Let us for now do this one, and this is going to be one very interesting discussion. As we can see the question, it looks too big, but I will shorten that for you. So what is said in the question? There is a rod, and this rod has a length of L, mass of M, and this has Q charge uniformly distributed along its length. Okay, then we have this electric field region, and it is basically divided into two parts. One region has a width of d, another region also has the width of d. In both regions we have electric field of the same magnitude. Difference is, here electric field is directed towards left and here it is directed towards right. So they are oppositely directed in these two widths of region, you can say. Okay. Now next is what? This rod is allowed to enter into this region of electric field with initial speed of u, and we have to go with certain assumption, like it is mentioned over here. When rod will be inside electric field, this electric field may distort the distribution of charge along its length, but it is said that we have to assume that it is staying unaffected by the presence of electric field. So here it is outside electric field, Q is uniformly distributed. Inside electric field also, Q will be uniformly distributed along its length. Done it? And also we have to ignore electromagnetic induction due to motion of the charged rod. So basically purely electrostatics thing is over here. Now let's go to the first thing that we are asked to solve. What should the minimum velocity u of the rod be so that it will completely pass through both the sections? So what should be this value so that it can cross this width of electric field and go in this space? Okay? So we need to actually understand what will happen with the rod when it will enter this region of electric field, and what will happen to the rod as it will progress from this width to this width. Done है? So these are the things we need to discuss. Let us start with this one. Suppose कर लो. Also one more important thing was there. Let me mention it. L length of rod is greater than 2d. ठीक है? So यहाँ पे मैंने छोटा बनाकर दिखाया है, but this L is actually greater than 2d. Now, the moment it will enter into this region of electric field, what will happen? Electric force will act on the rod. Why? Because as even the little portion of rod, if that is inside this region of electric field, it will experience electrostatic force because of positive charge upon its length, right? So let's say x length of this rod is inside electric field. What will be the amount of force acting on it? So let us define first lambda, that is charge per unit length on the rod. So on this x length, how much charge will be there? So let's call it dq, or let's call it q dash. So that is equal to lambda x. And since this lambda x is a positive charge, on positive charge, force will act in the direction of electric field. So this rod will experience force in this direction because of electric field present in this region. So initially it started with u speed. The moment it will enter this region, it will feel this resistive force. So this force will try to de-accelerate the rod. Done it? But because of the velocity force, I mean because of it having velocity, it will keep on moving, right? So, I mean, if it has to reach here, it should be able to cross this region. First of all, after that also we will analyze what will happen. Let's say it has entered into this region. Now in this region, I mean, now what is the net force acting on this rod? So if you see here, this length of the rod is inside this region of electric field, right? And this length of the rod is in this region of electric field. So let's say this is x, and this is clearly what? This is clearly d. So what is the amount of charge which is facing electrostatic force in this direction? Will be because of charge present on d length. So that is lambda d. Done hai? And force will be equal to q into e. So this is this much force in this direction, and lambda x charge is on this portion of the rod, and here electric field is in this direction. So electric force because of charge on this portion will act in this direction and it will be this much. Clearly you can see here, this first one is greater than second one. So still resistive force is acting, right? And net force you will define here as lambda e को आप common ले लो d minus x. So still rod is getting deaccelerated. So it has enough speed initial so that it can resist, or it can go against the will of this resistive force into this width of electric field, right? So इस region को तो cross करना है, साथ साथ इस region को भी cross करना है. Let's say because of its enough strong initial velocity, it is able to reach over here. Done है? And when the rod is in this position, you can see here d length is in this region, d length is in this region. So here this much charge and here this much charge. This charge is facing force this much in this direction, and this charge is facing this much force in this direction. Overall force you can see it is 0. So now there is no force, and if it has reached here and its velocity has become just zero, it's not zero, just zero, then also it will be able to push itself outward, right? So in order for u to be minimum such that this rod will be able to cross this 2D width of electric field directed like this way, then conditions should be what? Conditions should be that when the rod is reaching this boundary at this point, its velocity should be just equal to 0 for u to be minimum. Done है? So I will be taking, again v cannot be 0. अगर v 0 हो जाता है, force भी 0 लग रहा है, it will stay over here like this. ठीक है? So there should be some momentum left, even simmering, even little momentum. Done है? So we will assume that v is almost equal to 0. Now we need to do the calculation. We need to calculate u ka value for this thing. When for what thing? For the case where if rod has reached to this situation, or if the rod is in this situation, then its velocity is almost 0. Let us talk about it now. अब देखो यहाँ पे we can use work energy theorem in order to solve this question. So its initial speed was what? U, right? So initial kinetic energy half mu square. Work energy theorem आप use करो. Work done by all forces is equal to change in kinetic energy. Here only force doing work is electrostatic force. So work done by here electrostatic force will be equal to change in kinetic energy. Finally, when it is reaching here, we are taking that its velocity has almost become equal to 0. So final kinetic energy will be 0, minus is half mu square. And we need to calculate work done. Okay? So what will be the work done when this rod is moving in this width of the electric field? So let us go with the force. Force kitna tha tumhara? Force was lambda x into E, right? So this is the length of rod which is inside this region of electric field. Now what will be the, let's say with this much length of rod inside, it is further going in this direction by distance dx. Then work done आप क्या लिखोगे? आप लिखोगे F dot dx. Now you can clearly see force will act in this direction. Displacement is in this direction. They are oppositely directed, right? Force का ये direction है, dx का ये direction है, right? So you will write here F dx cos 180. So that will give you how much? Force का value आप लिख लो lambda x e, and that is, so we are calculating a small work done, right? So lambda x e dx cos 180 minus. So this is the value of small work done. So total work done, if you want to calculate when this rod has entered, is just about to cross this width of electric field. In that case, up to that point, how much work has happened? So, आप work done निकाल लो. Work done will be equal to how much? Lambda e x square by 2. And this will be equal to how much? X will vary from here to here. So, it will vary from 0 to d, right? So, lambda e d square by 2. This is the work done with negative sign. So definitely you can see work done is negative here. Force and displacement are oppositely directed. So this is work done. अब देखो यहाँ तक तो rod पहुंच गया. It will further enter into this region, then only it will be in this situation, right? So let us move to the second situation. When rod has started entering into second region of electric field, how you will write the net force acting? So this region, in this region d width of rod is there, and in this region let's say x width of rod is there. So here total force acting will be lambda de in this direction, and here total force acting will be lambda xe in this direction. Still lambda d is greater than lambda xe, so net force is towards left, और आप लिखोगे lambda e d minus x. Now, what will be the displacement? Let's say with this much length of rod, x length of rod inside second region of electric field, it is further moving towards right by distance dx. So what will be the small work done for this displacement? You will be writing f dot dx, and again f dx cos 180, because angle between net force and displacement is 180. So this is minus f dx, and if you write the value of f, this is lambda e d minus x dx, and you will here integrate it, right? So work done will be this much, and x will vary from where to where. X we have measured from here. So here it was 0, and here it will become d. So 0 se d aap kar lo. Work done will be minus of lambda e dx minus lambda e x square by 2. This will vary from 0 से d. So work done कितना आ रहा है आप वैल्यू पुट करके देख लो, माइनस lambda e d square minus lambda e d square by 2, right? So this is equal to how much? This is equal to lambda e d square by 2, ठीक है? And this will be minus this much, ठीक है? So this is what we are going to get. अब आप ध्यान से देख लो, what was the work we got in the first case? In the first case we got this much. In the second case we have got how much? Same amount, minus lambda e d square by 2. So what is the total work done? Now let's go back there where we were calculating that work done wala thing. So it was here, right? Done it? So work done by electrostatic force is equal to how much? Let me write it here. Okay. So how much is that? Minus lambda e d square by 2 minus lambda e d square by 2, and this is equal to half minus of half m u square. So this is equal to lambda e d square is equal to half m u का square. Lambda को ब्रेक कर दो. Lambda क्या था? Charge per unit length, so q by l. And here this will become, u will become how much? 2qe by ml root under into d. So this will be the minimum value of speed such that this rod will be able to cross this width of electric field over here. Done it? So this will be your answer. In second portion, what we are asked, if the rod enters the first section with a velocity which is double that of velocity obtained in the previous part, with what speed will it emerges out of the second section? Done it? So, I mean, if you are letting it enter this rod, if you're letting this rod enter into that width of electric field with velocity 2u, then with what velocity it will come out? क्योंकि देखो अगर u speed था, then it will just be able to come out, right? So it will start coming out with 0 velocity. Done it? So that was the case over there, but here since it is having double of u, it will come out with certain speed, and that we need to calculate. So let us go with this one. कैसे करेंगे हम? So, I mean, we just need to see in all this whole process how much work will happen in which whole process. I mean, it just entered into this region with a speed 2u. So first it will be reach up to this point. It will deaccelerate, and then it will reach up to this point. It will further deaccelerate, right? And then it will start coming out of this region like this. So I mean, if you know in this whole process, like then it will, in the third situation it will be, finally it will look like this, and finally it will come out like this. So कुछ ऐसा phase में वो बाहर चलता जाएगा, right? So if we know what is the work done in the whole process, then we can write that as equal to change in kinetic energy, because initial kinetic energy is how much? Half m 2u का square. So final kinetic energy आप ले लो half mv square. Let's say with v speed it is coming out. So final is this. So if we know how much work has happened in this process, we can easily do it, right? So work done until it has reached in this situation, we already know that is equal to minus lambda d square e. अभी अभी हमने कैलकुलेट किया, राइट? चलो अब हम वहां पहुंचते हैं when this rod has started coming out. So first it will leave this region of electric field, right? So while it is leaving this region of electric field, how much work is happening? Let us calculate that. So work done while this rod will travel this width of electric field, कितना लिखोगे? So net force F net dot displacement, right? So this is what we are going to do. अब देखो यहाँ पे this much width is, this much length you can say, is inside this region, and let's say this is x. So this is inside this region. Okay. So what will be the net force? Here charge will be how much? That will be equal to lambda d. Okay. And force will be lambda d. In which direction? In the direction of electric field. So in this direction. And here charge will be lambda x, electric force lambda xe in this direction. And clearly you can see lambda de is greater than that of lambda xe. So F net is towards right, and this is lambda e को आप common ले लो d minus x, and this is towards right. Now let's say in from this position it is further moving in this direction by distance dx. So what will be the small work done for that case? That will be equal to lambda e d minus x dx cos 0. Why 0? Because angle between net force and displacement is 0. Now net force is in this direction, displacement is in this direction. Okay? So this much you are going to get, and what will be the answer? If you solve it, lambda e d minus x dx, okay, and integrate it, x will vary while it is coming out of this region, x will vary from 0 to d, right? So this will vary from 0 to d. So work done will be equal to how much? Lambda e d square by 2, if you carefully solve it. This is a very simple integration, right? So it will be this one. Now what will be the work done when this rod will be leaving this portion? Okay, so while it is leaving this portion, what will be the work done? Again, you calculate the net force. So here net force is lambda xe, if this is the x length inside, and force will be in this direction because this is the direction of electric field over here, and charge is positive. Positive charge में force electric field के direction में लगता है. Let's say further it is getting displaced by distance dx, then work done will be equal to how much? F dot dx. Here f dx cos 0 because angle is 0 degree. So you will be writing f का value आप क्या लिखोगे? Lambda xe dx, x will vary from 0 to d. So while it is traversing this space, I mean x will vary from 0 to d. So this will be equal to lambda e d square by 2. अब तक आपको आंसर मिल चुका होगा. So total work while this rod is leaving this space of electric field is how much? Lambda e d square. And what was the work done when this rod was entering into this width of electric field? That work done was minus lambda e d square. Okay? So while exit this is, and while entering it is this. So total work done will be how much? It is 0. So if work done by force is 0, change in kinetic energy has to be also 0. So if change in kinetic energy is 0, it means it will simply, if it had entered with a speed 2u, then it will also come out with a speed 2u. Okay? So this is going to be our answer. So this way we could have solved it. Also you can use here, acceleration formula in order to solve for minimum speed, minimum value of u, so that it will be able to just cross this width of electric field. Okay? How? Because you can write the force formula you have already written. So if x length is inside, then force is how much? Force is your lambda xe. We have done it a lot, right? So this force is in this direction and it is getting displaced in this direction. This will provide it with negative acceleration, that is retardation, and that will be lambda xe by m. ठीक है। एक्सेलरेशन को आप कैसे लिखते हो, v dv by dx you can write with negative sign. Why? Because this is deceleration. And then v dv can be written as lambda e by m x dx ऐसा, and ऐसा with here with negative sign, right? So you can calculate what will be the velocity of rod when it has reached to this position. So that you can calculate from here. Initial is u, let's say final is v. So and initial x is 0, final is d, for this reason. And once you know what is speed over here, you can start working for its velocity thing when it is traversing in this region. So in this region, net force acting is lambda de minus lambda xe. Okay, again it will give us d acceleration. So in this case, it will become lambda e d minus x, and this will be equal to how much? Minus v dv by dx. Again, you can go from velocity at this point, that is we have taken v to 0. So here limit you can take as what? Lambda e, uh, okay, this is the force by m karoge, by m d minus x dx. Here limit will change from 0 say d, and velocity limit, you have to be careful with this one. This will be equal to how much? From v to 0. So from here also you could have got minimum value of u. ठीक है, ऑल्सो सेकेंड पोर्सन भी आप कैलकुलेट कर सकते हो. सो आई एम जस्ट गिविंग यू आइडिया ऑफ इन what different ways you can proceed with this question. I hope it is clear. I know I have taken so much of time to solve it, but just to explain more to you. ठीक है, but if you have got this question, you could have done it in some 4 or 5 minutes. By I mean, some minutes you will be giving in reading the question, 1 minute, 30 seconds, more than 30 seconds you will be giving, then in analyzing the situation, and then in solving the question. Solve करने में time नहीं लगेगा, क्योंकि अगर आपने situation को सही से scan कर लिया है, you will be able to see कि work done कैसा कैसा है, and whatever things will be there. So I hope you have understood, but if you have doubt anywhere, you can always let me know in the comment section. Thank you. Take care of yourself, and keep on solving more questions. Bye bye. Take care.